usage of the term in the previous slide is quite different from what we are going to discuss today. Some of the key ideas that I found from back then that really resonated with me and that expresses the essence of what middleware is are terms like glue. It's an interface between hardware found above the transport layer but below the application environment. I can't really exactly express why, but somewhere those terms gives me the essence of what we truly use middleware for today. Of course, we're not talking about hardware, but generally just as a glue between different parts of our application. Now, for today, consider a web application which consists of one or more API endpoints or views. Middleware is code you write to implement functionality that is common across one or more of your endpoints or views. Examples: count of page views, centralized error handling, caching, and many others. The WSGI specification PEP 333 describes middleware as a way to provide extended APIs, content transformation, navigation, and other useful functions. This leads us to our second topic of the talk, middleware for WSGI applications. I will start us off with discussing Flask applications. Consider a very simple Flask application where we create a blueprint and define a single route which handles all the requests. And let's refer to that as the view function. Now, of course, I've omitted a bunch of stuff from here because they're not relevant in this context. To define middleware in Flask, we use decorators. One example of a decorator that we use is the before request decorator. When you create a function or define a function and decorate it with the before request decorator, that function always gets called before your view function gets called when a request has been made to the application. Similarly, if you want a function to be called after the request has been processed and the response has been generated, you decorate it with the function, with the decorator after request. Now, of course, here I've shown the example of blueprint, but this equally applies to non-blueprint applications as well, just to be clear. A typical example is shown here as a use case for where you might want to use this. So let's say you want to print, or not necessarily print, perhaps record the latency of your page rendering. So what you would do is you'd use the Flask G global variable to start a timer in the before request function or the function where you decorated with before request. And then in the function you decorated with after request, you'd find the difference between the time now and the time that you recorded at the beginning of the request. And that gives you the latency of your page rendering. So that's marked as an optional because I may not have time for it. If you do check out the slides, I think that might give you more insights into how this before request and after request are implemented within Flask itself. Now, it's very common to define not one, but multiple such before request, sorry, not define. Let's rehash that. It's very common to define multiple functions which you decorate with before request as well as after request. Now, the ordering matters. For the before request functions, which I have specified here as before request underscore F1, before request underscore F2, the order in which they are defined is the order in which they are called. For the after request functions, they are called in the reverse order. So when the response is generated from the view function, the function you defined last gets called first, and then subsequently the other functions in a last in, first out manner. Okay, let's consider a Django application now. This is a simplified view function, which I have called index. It takes a single parameter, request, which represents the current request that is being handled. Please keep this in mind. This is going to be our key for the next couple of slides. So in Django, you can define a middleware using two approaches. You can define a class, or you can define a function. Now, the first example I have here is a class-based approach. You define a class, you define a constructor, which takes in a single parameter, getResponse. This parameter represents either the next view function or the next middleware to be called. The magic really happens here in the magic method call. So what happens here is, the first thing note here is the parameter that call takes. It takes a parameter request, which represents the current request that is being handled. And this is exactly what the view function also took in as a parameter. Now, in the call method is where we implement our middleware. Now, in this case, the middleware we are implementing handles exceptions. The desired behavior is, if there is no exception, we return the response as it is. If, however, we got an exception, we want to return a custom response. I have omitted that from here for brevity. Code is really hard to put on slides in a way that actually it's legible. So I've omitted that from here. And that's your middleware, which is using a class-based approach in Django. A function-based middleware looks as shown. We define a function called, of course, you can call it exactly what your middleware does. So in this case, I'm calling it as latency_reporter, and because I'm measuring latency of a request using this middleware. Now, the key here is the latency reporter function takes in a parameter getResponse, which points to the next middleware or the view function that will be called for the request. Now, this function returns a closure. That closure is, again, taking that parameter request, which represents the current request being handled, and that is returned. And the Django middleware machinery invokes this function whenever a request is being handled. Now, inside the closure, what we do is we again start a timer with and assign it to a variable request_begin, and then we go through. And then we call the view function or the next middleware, which is getResponse. And then after we have got the response from that function, we can print the latency here. In a more practical use case, you would push the latency to your monitoring system and then return the response from here. Now, once you define your middleware, this is how you activate those middleware in Django. You update your settings.py and you point and you update the middleware list, which is a module level variable, to the middleware you want to activate. The ordering here matters, once again. So consider that we have a middleware A, B, and then we have your application handler or your view function, whatever you want to call it as. So when a request is being processed, like basically when the request is coming into your application, first the middleware A is called, then your middleware B is called, and then finally your view function is called. Once the response has been generated, the response first goes into middleware B, and then goes up to middleware A, and then finally to the client. One key difference between Flask and Django middleware is that in Flask, your middleware may not be invoked for both parts of your request, that is, for the request as well as the response. Because you control that with the decorators before request and after request. In Django, it's different. Every middleware that you define gets both the request as well as the response. It depends on your middleware whether you can ignore the request or you can ignore the response. It really depends on what your middleware is trying to do. So to recap, using middleware, you define custom code to run before and after request processing. And how the middleware works is a framework-specific detail, which you usually can find out by looking up the framework source code. I did it myself, but I have omitted it from today's talk because I will not be able to cover it within the time. I thought I had a 45-minute slot initially. And WSGI frameworks define their own mechanism to define the middleware. So let's pause a bit. So as we have seen, we write a middleware for Django application, and we write a middleware for Flask applications. And the way we do it is quite different. And the reason it's different is because each framework implements their own mechanism. Now, my question is, could you write middleware in a framework-independent way? It turns out we can. These are, after all, WSGI frameworks, which means they define WSGI applications. And there lies the answer, as we shall see next. So I'll take a step back and define what is a WSGI, a function which incidentally is a WSGI application. I don't know how many of you actually know that this is a WSGI application. I mean, I knew something like this is how you define a WSGI application, but before I did this talk, I had no idea. But this is how a WSGI application looks like, and that is it. You don't have to do anything else. So it takes two parameters, a dictionary called environ and a function start response. The dictionary environ contains key value pairs describing the current request, and start response is a function which you use to send back the response to the client. So the commented lines are where you do your processing in your handler, and then when you're ready to send the response, you first call the start response with two arguments. The first is a string containing the HTTP status, and the second is a list of headers that you want to add to the response. And then you send back the response itself. The response needs to be an iterable. So here it just contains a single byte, hello world. Let's look at how we can write a WSGI middleware. So it looks very similar to the Django middleware with certain differences. In fact, let me go back to this. It looks, if you look at the call method, we'll ignore the init because it's not relevant here. I mean, it's quite clear, I hope, what it's doing. The call method signature and the WSGI application signature is exactly the same. And what we do here is, once again, one of my favorite examples, it seems like, to handle exceptions. So what I do in the call method is I call the self.WSGI app attribute, which points to the original WSGI application. If there is no exception, the response is returned as returned by the WSGI application itself. If, however, there is an exception, I call the start response with a 500 status with some custom headers. And then I return a custom response, which is an error occurred. And that's really useful because you hide your internal exception details from your client. You should, however, log it, which I haven't shown here. And how do you integrate the WSGI application with the middleware? It looks like this. You create an object of my exception processor type, which is the middleware we defined, and you pass in the WSGI application itself, and that's your WSGI app. And you can use a server like Unicorn app to run it. And there you go, you have your WSGI application running with WSGI middleware. I'm going to refer to this as the wrapping technique of defining middleware for WSGI applications. So let's pause again. So frameworks implement their own mechanisms to define middleware, as we have seen. Now, WSGI middleware is another WSGI application. So that means if we implement a functionality using WSGI middleware, they are framework independent. Let's see how they work. So this is the OpenTelemetry WSGI middleware. It's an open source middleware that's available from the OpenTelemetry project. It doesn't quite matter, so I'll not get into what OpenTelemetry itself is, but this is an example I was familiar with of a WSGI middleware. So this is the source code of the middleware, and you can see the similarity with the middleware we defined here. It's pretty much the same if you ignore the specific functionality. So that's the OpenTelemetry WSGI middleware, which is available as a third-party package, right? And how can we use that with Flask? So when you define a Flask app, there is an attribute WSGI_app, which points to the WSGI application. And what you can do here is we set the attribute to an object of the OpenTelemetry middleware type, which we create by passing the original WSGI app as an argument. So this results in the OpenTelemetry middleware wrapping our original WSGI application. And that basically gives you the functionality that the OpenTelemetry middleware provides for your Flask application. Now, for Django, if you look at the file wsgi.py in your project, you will find this code where there is a top-level variable called application, and that gets set to the return value of the function getWSGIApplication, and that points to your underlying WSGI application. Remember when I said that this frameworks abstract a lot of these things, but somewhere in there is a WSGI application, so this is the WSGI application. And the way we use the OpenTelemetry middleware, it looks similar to Flask. We create an OpenTelemetry middleware object, we pass the original WSGI application, and then we update the value of the application, which is the module level variable, to that object. And that's all you need to use WSGI middleware. So this sounds like a win, right? Like you can write a WSGI middleware and you can use it in a framework independent way. Now, I'm not sure if there are any pitfalls to doing that, though. I haven't explored it enough, but maybe that's something for you to go and explore back home. All right. So let's see one last example of how we can use a middleware. Consider that you have a Django application and you're moving some of your backends to Flask. What you can do is you can define a middleware which embeds the Flask application within your Django application. If it sounds like magic, that's how it seemed like to me when I actually implemented it. So you define a class called, you can call it anything really, but I have called it Flask app wrapper. The key again is the special call method. So here I call the Flask app's WSGI app method first. I pass the environment and start response exactly how I found it here, and I pass it to the Flask app. If I get a non-404 response, I return the data as it is, and that indicates to me that that request was handled correctly. If, however, I get a 404 response, I fall back to the Django application. And that's one way you can use middleware to help you in migrations, perhaps, in your project. And this is how you use it. It looks very similar to how you use the OpenTelemetry middleware. So the result is, when you make a request to the polls v2 path, the Flask application gets called. But when you make a request to the polls path, the Django application gets called. So to recap, Flask and Django implement custom mechanisms to allow users to define middleware. However, as you have seen, when we define a WSGI middleware, they are framework agnostic. And we can use the wrapping technique to use this WSGI middleware. Okay, how much time have I got? 7 or 8? Eight, okay, good. So this is going to be like a turbo section, I think, but let's see. So this is an ASGI HTTP application, right? And it's similar to what we saw for the WSGI application. You define an async function. It takes 3 parameters, a scope, a function receive, and a function send. Scope essentially describes the current request. You can think of it as the lifetime of the current request. The receive function is used to get any request data, and then you use the send function to send back any response. So remember the signature. That's all that's needed for this section. And I'm going to skip over this because we'll cover it later. Okay, now let's consider a FastAPI application. This is how you define a very simple FastAPI application. You create a top-level object of FastAPI type. We define a route, expensive, and it's a super expensive route where we sleep for 10 seconds, and then we return a response. Now, let's say I want to write a middleware as a caching. Like I want to cache these expensive results. I don't want to calculate a result every time. So what I do, I define a middleware. I define an init method. It takes in 2 parameters. The first parameter is the ASGI application itself, and I have a second parameter, excluded paths. Now this is any custom arguments that your middleware needs to take. And we can specify as many as you want here. I just have one. The key here, again, is the special call method. It should be an async function. It takes in 3 parameters, scope, receive, send, exactly like our ASGI function here. And in this function, we define the logic for the middleware. If there's a cache hit, we return the cache response. If, however, we did not get a cache hit, we call the original app using the original arguments, scope, receive. Cache and send is a wrapper that I created, which caches the response and then sends back the response. You can find these examples in the resources I have shared in my website. And so, again, you have defined the middleware. How do you add it? In FastAPI, it provides a helper method, add middleware. And you first define the class of the middleware that you want to add, and then you specify any additional parameters. In this case, I have got a parameter called excluded paths, which is a list of paths I don't want to cache. So chat actually is a WebSocket backend, which I've implemented. And that brings me nicely to my next slide. So this middleware actually works very well as for HTTP applications as well as WebSocket applications. And the key to that is because the scope lasts as long as WebSocket connection remains open. So when we call this await serve.app, that function doesn't return as long as the WebSocket connection remains open. So I've got some logs down below where you can see that the request lasted for 30 seconds, which is how long the WebSocket connection was open for. I will skip over this. You can look at the slides. OK, so now if you notice, if you compare what the default behavior of the WSGI framework and the ASGI framework is, I quite like the default behavior of FastAPI because it allows you to define ASGI middleware directly. In fact, that is the first thing they recommend in their documentation. They talk about a more specific approach later on in the documentation, but I quite like the fact that they ask you to just write a generic ASGI middleware, which means if there are other ASGI frameworks, you could use the middleware with those as well. I quite like that about FastAPI. So, OK, the last middleware example you're going to see is how can you embed a WSGI application inside an ASGI application. This is as magical as it gets. So what you can do is you define a FastAPI app, and then FastAPI provides a special middleware called WSGI middleware. You call the mount method, and any paths starting with v1 will be passed on to the WSGI middleware and hence to the WSGI application. And the result is, I've got a brief example. So when you call anything with v1, you get hello world from Flask because that's being processed by Flask. On the other hand, when you call anything with v2, you get a response from the FastAPI application. The WSGI middleware implementation, if you look in the Starlet source code, looks like this. I'm sure you're beginning to see the sort of pattern now. So you look at the call method, takes in 3 parameters, and then there's the special WSGI responder class, which if you go into, it defines a WSGI method which takes in 2 parameters, which is an environ and start response. So your WSGI application essentially. I will skip that. So key takeaways. Middleware can be defined generally as an WSGI or ASGI application, or be framework specific. Middleware is code that's acting as both a client and a server. A client for your other middleware or for your views, and as a server for other middleware or for your original client. And middleware enables decoupling and sharing of non-functional requirements. And it also helps us in migration between application frameworks as well as WSGI and ASGI. So I have an exercise for you. Go back, not today, maybe after you have recovered. Check out the source code for the built-in middleware and the community contributed middleware. Or you will easily be able to see the pattern, and hopefully the talk has given you enough to really go dig deep into those and understand how they work. So Thank you. Thanks for choosing my talk over some of the other excellent options. And I hope you have gained insights into the internals of the middleware as they apply to WSGI and ASGI applications, and go away with a few new neural pathways formed in your brain. I have written a few books. Those two are my books I'm most proud of, I guess. Go, yes, I know it's a Python conference, but I'm a Python as well as a Go guy. So please check out that book if you're taking your first steps into Go and looking for something practical. And Doing Math with Python, I wrote that a few years ago, but I think it's still relevant. So please check it out. Feel free to contact me with anything related to this talk or anything else really. Yeah, that's all I have. Thank you.